So, what's known as the inverse square law, and it's not a law, it's a mathematical principle, says that in certain cases that functions will fall off as 1 over r squared. And when we're talking about physics, that this function is some of these invisible forces, these primary forces in the universe. It turns out that inverse square law starts referring to when you see it in application, when you see the inverse square law, you start looking at the fundamental forces in the universe. Okay, so with the inverse square law, we have with several big forces that we're going to talk about. The other fundamental forces we're not going to deal with, but there are 2 that we will deal with. Well, 3 actually. Which actually the magnetic field is not going to fall off quite what we expect it to be. So the first fundamental inverse square law force is going to be universal gravity. The gravitational force that we feel in the universe. So we'll call that force gravity. The second is going to be Coulomb's law, which is K, Q, Q over R squared. So these are the 2 real big inverse square laws that we need to worry about. Like I said, there is a magnetic field. It didn't quite fall off the way we expect, but nevertheless, it's there. Okay? So here are 2 of my fundamental forces: gravitational and electrostatics. So gravitational dealing with 2 mass, electrostatics dealing with 2 charges. Okay? Now, what makes these inverse square laws is this 1 over r idea, a product divided by r squared. Okay? Which means that if I were to look at how forces behave in that system, they'll start off very, very strong and quickly decline into nothing. Okay? They'll start off with a lot of power, really, really close, a lot of strength, and then quickly disappear to almost nothing. Now, it never turns into absolute 0. The only time that this function ever goes to 0 is when r squared is equal to infinity. So when I look at a system, I know that the force of gravity is 0 at infinity, but in all actuality, no object in the universe is at infinity. We can make an assumption, let's say that Alpha Centauri, which is the closest solar system to our own, might as well be at infinity, and everything beyond that, because the gravitational attraction we feel from Alpha Centauri is almost absolute 0. Okay, but just like I said really briefly, this is the inverse square law, which just means that the force falls off as 1 over r, and it goes on to infinity. These forces go out to the very reaches of the universe. We feel a gravitational attraction from every object in the universe because they have to be an infinite amount of distance away from us not to be affecting in one way or the other. It just turns out that because it's 1 over r squared, that the force of gravity, or even the electrostatic force, which is considerably stronger than gravity, really don't play much of a factor unless they're incredibly massive objects or incredibly short distances. Okay? Cool? So that's a real brief rundown of the inverse square law.